Welcome to the Vision Break. In this video, I will show you how to train custom YOLO-NAS object detection models. Let me quickly show you what are we going to do. First, we will prepare our dataset and we will set up our environment. Then we have 6 main steps: install necessary libraries, dataset parameters. Then we will create 2 different sets, train and validation sets. After that, we will choose pre-trained YOLO-NAS model. Then we will configure training parameters like batch size, learning rate, and other things. In the end, we will train our model. Let me show you training process. Yes, you see. And after that, we will save this trained model and we will load it again and test this model on test images. Yeah, you can see. By the way, I will share link to this article in comment section. You can read it or watch the video. It's up to you. You can copy all the code from this article. I think I can start. Okay, so I'm not gonna create a dataset from scratch. I'll use this dataset. I found it from RoboFlow. Let me show you a few examples. We have some problem. There's error, it says, but okay, no problem. So you see we have 3 different class: player class, referee class, and all class. Let me show you a few examples. Yeah, you can see the image. So you can download it like this. Go to the dataset, download dataset, and you can download it as zip, but I didn't log in. I don't want to log in for now, but you can download it like this. And now we will set up our training environment. For training a custom YOLO-NAS model, you need to have GPU supported PyTorch environment. I already have one. Let me show you. Import PyTorch, and now I'll print if CUDA is available. Torch.CUDA is available. It might take like 5 seconds, I don't know. Okay, so it says true, so this means that training will be done on GPU, not CPU, so it will be like 20 times faster. But if you don't have PyTorch, a GPU supported PyTorch environment, you can always use Kaggle. Go to the Kaggle. So create notebook like this. And after that, there will be settings section. From there, you can activate your GPU, but I didn't log in and I don't want to log in for now. So you can click this setting and activate GPU, then train your model. Yeah, okay, this step is finished. And there is one additional video. If you have NVIDIA GPU, you can create GPU supported PyTorch environment. Like, you can watch this video. But there is
Grammarly.
Yeah, anyway, you can click this link and watch this video. I used this video like 1 year ago and still my environment is okay. It's working. So we can continue. And you need to install super gradients beside PyTorch. So let me import these. Okay, let me print device as well to see if GPU is available. Yes. So this there's nothing special. This experiment name is basically all the model files will be under this directory. What's the other step? Define dataset parameters. Okay, let me copy this. So we need to change this path to here. And by the way, I download that dataset. You can see the zip file and I unzip it to here. Let me show you the format. So there's two subfolder, train and validation. Under these folders, there's image and label folders. You can see some training images and this labels. It contains text files. So this is YOLO format. You see first one is label ID and coordinates. For example, this 2 means I think player because there's too many 2 in this label list and text files. You see. So this is YOLO format. If you want to, if your dataset is in Coco format or any other format, you need to change some parts, but I don't think there will be any problem because there are functions for it. You just need to Google it, you know. And here we are creating instance of trainer class. You see the trainer class here. This is experiment name. We just here you can see we just write it. Oh, we have a problem. We need to delete this 5. And we have 3 class, player, referee, and football. It might take some time. You know, it. Oh, I didn't change this. Sorry, my bad. Let me copy this, copy path. So there will be error, but before that I want to change that. Yes, okay, error, but no problem. Okay. You see this is path to the base folder here. And train image, train labels, same for validation, and we have class names. We can continue. Okay, now we will create 2 different sets, train and validation sets. You see Coco detection YOLO format train, so it basically converts YOLO format to Coco format. You can think like that. If you are directly using Coco format, you don't have to use these functions. So here we have batch size. Depending on your GPU's memory, you can increase this size, but I have an old GPU, so I will stick with 4. But you can use 8, 16 or 32. So you see we are using this dictionary again, like base directory, train directory, batch size, and same for validation. Okay, no problem. And now we will choose pre-trained YOLO-NAS model. Let me quickly show you. Yeah, these are pre-trained models like YOLO-NAS small, medium, large, and int8 versions. You can see mean average precision values. So these value basically presents combination of precision and recall values. And this latency it's about FPS. So lower the latency, higher that you will get FPS. Higher FPS that you will get. But I will stick with medium model. Let me execute this. So if you have like powerful GPUs, you can use large model as well. Okay, we have number of classes here, and we are using Coco pre-trained weights. Nice. And now we will configure training parameters. Let me copy this. So you can see there are like learning rate, initial learning rate, epoch number, or for example, we'll watch mean average precision while training. Yeah, you can change these values. It's up to you. Let me execute this. Okay. Sorry. And now we will train our models. So you see model is, wait, I want to show you training parameters. Yes, we just created this. We have train data and validation data. You see, oh sorry, train data and validation data. We use this dictionary, this dataset, and you can see our model. This model. So this is our model. Yeah, I think we can start the training. Let me execute this. So we will train for 20 epochs. Okay, training is started, but it will take, I don't know, more than 30 minutes, I think. So I'm not gonna wait, but after training is finished, I will continue. Okay, now training is finished. I want to show you 5 epochs. For example, epoch number 2, you can see some values, but let me show you last epoch. Yes, this one. Oh, sorry. Yes, here. You see training is finished. And if you want more detailed information, you can go to this checkpoints folder. And here you can see some logs. This one. You can see for each epoch there are loss values. For example, learning rate. So You see other like library versions as well. By the way, we remember when we start, we declared this name, and this is same as this folder. If you write something different, for example, YOLO-NAS module demo, it will be YOLO-NAS demo, this folder. Let me show you. Yes, this one. Okay, we have one more additional step. Yes, now we will use this trained model and make predictions, and we will test our model. So, for example, we can use this best model. It's best model based on metrics, of course. We are not deciding that. Okay, we are loading our model and we are using GPU for faster inference. Okay, we will load our image. Yeah, I have some test images. We can use those. Copy path. Oh, sorry. Oh, I didn't copy the paths. Just like this. Okay, so we are reading image and again we are using model. There's some confident value. You can change this. Okay, this is our prediction. You see, and now let's see it on image. So we have one problem. The sequence of the dictionary is wrong. Let me change that, probably like this. Let me check. Yes, now it's true. You can see the players, but we have one more image. Copy path. Actually, this is test 2. We can directly write it like this. Okay, again prediction. You can see the bounding box coordinates, labels, and confidence values. Okay, you see player, 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 player. So yes, I think, let me check if there's additional step. Yes, okay. That's it for this video. Thanks for watching and see you soon.